Let's look at how we calculate a raw score that corresponds to a specific percentile when we've got a normally distributed variable. For example, let's go back to our chips example, where at this restaurant, the average customer eats 8 chips with a standard deviation of 5. So that means most customers ate between 3 and 13 chips. Now, our question is, how many chips would someone need to eat to be in the 75th percentile? So we want to know what the cutoff is for the 75th percentile to be of the chip eaters. Who's going to be in the top quarter of the chip eaters? Who's going to be in the bottom 75% of the chip eaters? To figure this out, we have to figure out, first of all, what z value has an area to the left of it that equals 75%. And then, once we figure out that z, we're going to convert that back to a raw score with the information that we have about the mean and the standard deviation. So first of all, we want to find the area to the left of z equals 75%. To do that, we're going to use the Excel command norm s inverse. So normalize standardized inverse to find a z, and that will give us an area that corresponds to the z. Now, we could say that's also the probability of getting a z score that's less than that value if we were to randomly choose one. And conceptually, it's the same. So the Excel command that we're going to use, and here I'm using Excel from within PowerPoint, I'm going to give the command equals norm s, so remember the s there, inverse, and then I'm going to put in the 75%, 0.75, close parentheses, and this will give us the area, this will give us a z-score that has an area of 75% of the curve to the left of it. And so that gives 0.6744. So that's the z-score that cuts off the 75th percentile in a normally distributed function. Now, we need to find the raw score, the number of chips that corresponds to. Now remember that z is the defining equation of z is the raw score, the number of chips minus the mean, minus the average number of chips, that difference divided by the standard deviation of the number of chips people have. So if we do some algebra there, that means that the raw score is going to equal the average number of score plus z times the number times the standard deviation. So for us, it's going to equal, now I could put the cells in here. I could put E11 for the mean, but I'm just going to put 8, make it a little simple. And then we're going to do plus z, so shift, or sorry, I'm going to do, shift plus, and the z is, I don't want to copy that. I'm just going to put in G11, and I'm going to times that by the standard deviation, and I could put E12, but I'm just going to put 5 there. And so that's the equation. The x-score equals the mean plus the z-score times the standard deviation. I press enter, and that comes out to 11.372 blah, blah, blah chips. So let's actually select those and go remove the decimal. So I'm going to home, general, number, and we get the numbers there. So 11.37 chips is the 75th percentile. 75% of the people eat 11.37 chips or less. And if you eat more than that, you're in the top 25% of the chip eaters.